Today's topic is still along the lines of transformations. We're going to look at dilations this time. We're going to divide this into two parts. The first part is what we're going to look at today, where we're actually dilating the figures. So again, our essential question, how can we best show or describe the change in position of a figure? By the end of the lesson, I would like you to be able to say, I can explain how two geometric figures are similar when you dilate, rotate, reflect, or translate the first to obtain the second. So we're kind of tying in everything that we've looked at up to this point. A dilation is a transformation that enlarges or reduces a figure by a scale factor. The scale factor, when I talk about it today, will be described with a lowercase k. To find the ordered pairs of a dilated figure, you're going to multiply the coordinates of the original by the given scale factor. So if you're given the point xy, you're going to multiply the x by that scale factor, and you're going to multiply the y by that scale factor. So for instance, if I wanted to dilate my figure by a scale factor of 2, essentially what we're doing is we're making it 2 times bigger. So I'm going to be multiplying the x by 2 and the y by 2 to give us our new ordered pair. A dilation will produce the same shape, but now, different from translations, rotations, and reflections, they are not going to be the same size. And you'll see a situation where it can, but that doesn't come up a lot. So what we're looking at now is the same shape, but not necessarily the same size. So let's talk about the scale factor and the value and what will happen to our dilated figure. When the scale factor, which is again your k value, is greater than 1, then the image is going to be an enlargement of the pre-image. So if the scale factor is greater than 1, then you're enlarging the figure. Just like the example I used prior with the scale factor of 2. It's going to double that figure, so it's going to be twice as big. When the scale factor is less than 1, then the image is going to be a reduction of the pre-image. For instance, if your scale factor is 1/2, then you're making the new image half of the original. And then, in the rare situation, they give you a scale factor that's equal to 1, then the image is going to be the same as the pre-image. So that's that situation where the shape will stay the same as will the size. But you won't see that a lot. Most of what we're going to be dealing with is going to be a scale factor that is either greater than or less than 1. Let's look at an example. We have triangle ABC, and we're going to dilate this to a scale factor of 1/2. That means we're going to take each of these ordered pairs and multiply those x and y coordinates by 1/2 to get our new ordered pairs. So for instance, A is currently at -6, 4. So the pre-image for A, -6, +4. We're going to multiply each of those, the -6 and the 4, by 1/2, which is our scale factor. So when we do -6 times 1/2, we get -3. 4 times 1/2, we get 2. So our new A is at -3, +2, which will be right here. Let's look at B. It's at 0, 8. We're going to multiply 0 and 8 by 1/2. So our new B is going to be at 0, 4, which is right here. And then C is at 4, -6. Again, we're going to multiply the 4 and the -6 by 1/2. So our new C will be at 2, -3. So we're going to connect these with our ruler. So hopefully you notice that our new figure is the same shape. However, it's not the same size. It's actually, to be exact, half the size of the original triangle ABC. So a scale factor of 1/2, less than 1, means that I have a reduction. My new figure is smaller. So we'll do more examples and activities tomorrow.